All right, over the next couple of days, we're going to be taking a look at some important properties or behaviors of waves. So we're going to go through some examples here in the notes, as well as you guys going through some stations to do some demonstrations of these properties and behaviors, so then you can see them firsthand. Okay, so our first property or behavior that we're going to talk about is reflection. So when a wave hits a reflecting surface, it's going to be reflected outward at the same angle as it came in. So we call that that ray that's coming in the incident ray, and we call the angle of incidence. Okay, so I like to remember that as the incident ray is coming into the surface. So that ray is going to hit a reflective surface like a mirror or the surface of water, or some windows can be reflective, and then that ray is going to bounce back outward at the same exact angle that it came in at. Okay, so that's going to be called the angle of reflection, and then the ray that goes off is called the reflected ray. So an example of what this looks like with a laser, okay, we've got a laser coming off here. Okay, it's hitting a mirror or some kind of reflective surface here, and you can see that that angle that it's going in at is the same as the angle that it's going out at. So that does not change. It does not affect the way that the wave is traveling overall. It just affects the direction that it's going. Another example where we see this is on the surface of water. Okay, this is how we get perfectly reflected images on the surface of water, because those light rays are coming in at one angle and leaving at the same angle. It creates the same image that you see up top. Okay. Another common characteristic that is usually talked about with waves is refraction, and this is one that you've probably had some experience with in your life, but you probably didn't necessarily realize it. Okay, refraction occurs when waves bend when they go from one medium to another, like from air into water or from air into glass. So that happens when a ray bends towards the more optically dense material. So let's say here we've got a light ray coming into some water here, going from the air into water. Okay, that angle is going to decrease because that ray is going to bend towards this more optically dense material, the water. Okay, now if we go the opposite way, that we have the ray leaving the water and going out into air, that angle is going to get bigger. Okay, because it's bending away from the optically dense material. Okay, so having a more optically dense material is going to cause a greater bend in that light wave. So some examples where we see this, okay, if you were to take a laser and point it into a tank of water, as shown in this picture, okay, you'd expect the laser to just keep on going through this way, right, in a straight line. Okay, however, when that laser hits the water, it bends a little bit, it slows it down a little bit. Okay, so that's going to create a different angle and almost make it look like the light is traveling in a different direction. We also see this when you put any kind of something in, like a glass of water, like a spoon or a straw or something like that. You see refraction when that happens because the thing that you put into the water looks broken. Okay, that's because the light rays that are going into that water are bending at a different angle and kind of skewing the image that you see in that water. So it makes that piece of material look broken because of that. Another example where we see refraction is with a prism, or raindrops do this on a rainy day. Okay, raindrops can act as a prism. Okay, different wavelengths of light are going to bend at different angles, which is what creates a rainbow. It's what makes a prism able to separate white light into all of the colors that make it up. Okay, each of these different colors have a different wavelength, as we learned when we talked about the electromagnetic spectrum. Red waves have a longer wavelength, while purple or violet waves have a shorter wavelength. Okay, so those longer wavelengths aren't going to bend quite as much, not as steep of an angle there. Whereas the ones with a shorter wavelength, they're going to bend a little bit more. So we get more of a bend in those purple waves. Okay, so this is why you can see a rainbow on a rainy day, because the raindrops act as a prism and break or refract that white light from the sun into the colors of the rainbow. So that's why you only see rainbows when it rains and then it's like sunny right after, or it's raining while it's sunny. Okay, you have to have both of those things to have that refraction. So here's some more pictures of what that looks like with actual real life prisms. Okay, so you may have seen pictures like this before in another science class, where you have the white light entering one side of the prism, the rainbow leaving the other side. This is also what makes lenses work. So if you wear glasses or contacts, okay, those lenses are refracting light to help you see. Okay, so what happens when you have some vision impairments? Okay, your eyes don't refract the light the way that they should to be able to focus an image the way that it should. So what a lens does, okay, in this example, this oval here is your lens, so that's your glasses or contacts. This is light that is coming into the glasses or contacts, so coming into your eye. That lens is going to help focus that light into your eye to be able to focus the image better. Okay, so without it, your eyes don't do that super well, so that's why the images look fuzzy, because the light isn't focused the proper way to create the definition that it needs. Another characteristic of waves is diffraction. So diffraction is one that you may not have heard of before. Okay, this occurs when waves bend when they go around obstacles or through openings. Okay, so here with this example, when these waves are going in a straight line towards this obstacle, this tiny opening, they can go through there, but they bend as they go through. Okay, because they have these longer edges that still need to go through. Okay, but they can't go through the same way that they have been. So they have to bend to fit through that tiny opening. So here's an example in this picture up here of what that looks like with some water waves. With a small opening, you get that nice curved wave pattern. This one, there's an obstruction in the way, so it causes the waves to have to go around that obstruction. Okay. Now, if you were to do this with like a flashlight or a laser, okay, that would create a little distorted image of that light source. Okay, so if you were to point a laser at a wall or something like that, you'd expect to see one single beam of light on the wall, right? Now, if you were to diffract that wave of that laser a little bit, okay, you get a little skewed image of that. Okay, your dot is going to kind of spread out a little bit. It's going to become more of like a line instead of a dot. Okay, so that's what would happen if you created some kind of obstacle for a laser wave to go around. Now, with interference, this occurs when two or more waves run into one another. They create an interference between their crests and troughs. So when you have two of the same things go together, okay, you're going to create a more intense version of that thing. So if you were to get a crest and a crest together, as shown here, okay, crest plus a crest, you're going to get a bigger crest or a more intense crest. If you get a trough and a trough put together, you're going to get a deeper trough or a more intense trough. Now, if you get two opposite things to go together, like a crest plus a trough, you're going to get a partially or completely canceled out wave. Okay. So we usually call, when we have two of the same things together, a positive or constructive interference. So a constructive, they build up to something bigger. If you get two opposite things, we usually call that a negative or a destructive interference there. So in this example, okay, we've got a pretty normal wave that we've seen many examples of, a normal transverse wave. Okay. In your notes, I would like you to predict what wave should go here to create this wave at the bottom. Okay. So pause the video here, take a second to do that, and then we'll move on to the next thing. All right, our next property of waves is absorption. So when waves are absorbed by a material, absorption happens. Imagine that. So lots of different materials can dampen or lessen or stop a wave. This is what is used in soundproofing rooms and usually used in music studios for soundproofing. So then that way it doesn't create a bunch of reverberation of those sound waves in that area, so you don't get a bunch of echoes where you don't want them. We also see absorptions in a lot of commercial products that we use. So for example, earplugs absorb sound waves so then they don't damage your eardrums. Shock systems in cars will absorb the bounciness of the ride if you are going over some bumps, or like here in Ohio you hit a pothole, okay? Those shocks will kind of absorb some of the energy that's created there, so then it doesn't create as bouncy of a ride for you. We also see this in the construction of a lot of modern buildings, okay? This is common in places that are more susceptible to earthquakes, okay? They're going to build those buildings with more materials that are going to absorb energy from the waves that are created from an earthquake, so then the building doesn't shake as much and there's not as much damage caused by that earthquake. So absorption is used in a lot of ways in our everyday life. We also see this underwater. Okay, various wavelengths of light are absorbed at different depths in water. Okay, so if you were to look at a series of vibrant colors like this, okay, just below the surface, okay, those are going to be much more bright colors because the light waves don't slow down as much just at the surface of the water. Now, the deeper you go into the water, the slower those light waves are going to move. Okay, now, that's going to mean that your colors become less and less vibrant, okay? So these two pictures here are the same exact thing, just at two different depths, and they look very, very different depending on that depth. Here's another example of if you took the same picture of a seahorse and some coral here, okay? Towards this would be what it would look like towards the surface, what it actually looks like, okay? Now, this is what it would look like if you were diving down there to the depths that they're actually at, and that's what it might look like to your eyes. Okay, it's not going to be as vibrant as you would expect it to be. Now, our last characteristic that we're going to talk about in this video is scattering. Okay, scattering occurs when reflected or refracted light moves in multiple random directions. Okay. So if you're looking at a reflective surface with scattering, okay, that light ray is going to come in and reflect out in all directions, okay? So that's not going to create that nice one single wave, that reflected wave that comes up like we saw with those laser examples earlier. This is going to create a skewed image and you're not going to see just one single wave coming back, okay? Now, if you have refraction with scattering, okay, you've got one ray coming in, the rest of that ray is going to be broken up and bend in a bunch of different directions, okay? So that's what creates this translucent glass that you sometimes see. It's more like of a privacy glass that you might see on like shower doors. Some offices have this like on the glass doors for privacy, okay? Because that light wave comes in and it's scattered, so it skews the image that's created to give privacy to the people behind it. So that is it for our properties that we're going to go over in our notes. Make sure you've got all of your blanks filled in, you've got all of the questions in this video answered, and make sure that all of your stations get done as well. Okay, if you have any questions on this, let me know. But once you are done with this and you're not working on a station, you can work on some vocab or one of those early finisher activities.